All right, starting with number 14. It's square root of all this stuff multiplied together. There's no dot here, but it doesn't matter. So we have essentially 2 times 6 times 10, all that under a square root, times square root of x to the 6th. Square root of x to the 6th, because there's 3, 4, 5, 6 x's, is x to the 3rd, because x to the 3rd times x to the 3rd is x to the 6th. And then under here we have a 2, a 2 and a 3, and a 2 and a 5. So the only pair we have is the two 2's here. So we end up with 2 times root 30. So put all this stuff outside the roots. We have 2x cubed times root 30, which is the final answer. Let's move to the next one. 15. So 15, we have the top of a picnic table is shaped like a rectangle. Let's draw it then. Its length is 4 times its width, so if its width is w, like it says, then its length must be 4 times that. What is the distance between the opposite corners of the tabletop? So from that corner to that corner, those are opposite corners. Well, we know that distance is the Pythagorean theorem, so we know the leg is w, so if we square one leg and square the other leg, we will equal the distance between the corners. So we just have to simplify this, and we'll know the answer. Well, kind of. W squared plus 16w squared, that equals 17w squared. And so, equal. So let's go back. So the square of this side plus the square of this side will equal the square of that distance, not the actual distance. So once we get the distance, which is 17w squared, right? There's the distance. We need to take the square root of that, right? So the distance is actually w times root 17 equals the distance between the points. If they gave us one more piece of information, we could actually figure this out, but since they don't, we just give them a simplified answer, so it's w root 17. Number 16. This is about the golden rectangle, which there is a specific ratio for that. I'm not going to test you on what that ratio is, and I don't know it off the top of my head, so I'm going to skip this one for now, and you don't need to worry about it. We're going to go right on to number 17. 17, we have 3 root 7 plus 8 root 7. Well, these are like terms, so 3 plus 8 is 11 root 7. Done. Easy. Number 18, we have 14 root 5 minus 10 root 5. Again, these are like terms. 14 minus 10 is 4, so 4 times root 5. Done. Number 19, we have 3 root 6 minus 8 root 6. Look at that, like terms. 3 minus 8 is negative 5 times root 6. Done. Those were easy. Let's go on to number 20. All right, for this one, we have 4 root 2 minus 3 root 18. These are currently not like terms, but 18 can be simplified. So 18 is 9 times 2, and 9 is a perfect square. So what we end up with is 4 root 2 minus, and then this square root of 9 is 3, so we have minus 3 times that 3 that's already out there, right? So minus 9 root 2, right? That seemed a little confusing. Let's try this again. So we have negative 3 times root 9 times root 2, right? Because here's the root 18. So that negative 3 times root 2 becomes negative 9 root 2. There it is. Now these are like terms. 4 minus 9 is negative 5. And voila, our answer. Which, yep, checked. Same as the answer sheet. 21. We have 25 root 7 minus 2 root 63. Same type of deal. These are not like terms, but root 63 is 9 times 7, so square root of 9 is 3. So when we multiply that to the negative 2, we will end up with negative 6, and that root 7 is still there. These are now like terms. 25 minus 6 is 19. 19 root 7. Final answer. Moving on. 22. We have 4 root 54 minus 3 root 150, which is one we've done earlier in the practice test. So 54 is what? 27 times 2. I think we've done that as well. So 27 is 3 times 3 times 3. That 2 is still there. So what we have is that minus, and then 150 is what? 3 times 5 times 2 times 5. So 2 times 3 times 5 times 5. Let's double check that. 25, 75. Yeah, okay. So these two make a 3, because the square root of 9 is 3, and these two make a 5. So we're going to have 12 root 6 minus 15 root 6. We do now have like terms. 12 minus 15 is negative 3. Then we have root 6. Confirmed. Moving on. 23. All right. A little more exciting, maybe. Let's find out. Root 14 plus root 3. Root 7 times root 14. Well, we're going to get a decently large number here, which I think will be like root 98. But more importantly, we just show that we're going to multiply them together, and we can do this a little quicker, I think. So, so right now I'm just showing that I'm going to multiply this times this and this times that. But I didn't actually do the multiplication because since we're going to put it in simplified root form anyway, we're going to have to break down the number, so it's just going to be easier to break it down from here. So this is a 7 times 2. So what we really have is the square root of 7 times 2. Here it's not going to really help because 7 and 3 don't have any pairs. But here we have a pair. So we have 7 root 2 plus root 21. And that is going to be the final answer, because there's nothing more to simplify. And we're going to go to 24. 2 root 3 times 2 minus root 6. Again, we are going to use the distributive property. So this goes to both items here. So 2 root 3 times 2 is 4 root 3, and then 2 root 3 times root 6 is 2 root 18, so minus 2 root 18. Again, 18 is a simplifiable number because it's 9 times 2. So we actually have 4 root 3 minus 2 times root 9 times 2. Root 9 is 3, so we can multiply that to the 2. So we get 4 root 2 minus 6 root 2. And then these are now like terms, so we have negative 2 root 2. Well, that one was all right. Oh, I just checked the answer. Looks like I've made a mistake. Going back. 2 root 3 times 2 is 4 root 3 minus 2 root 18. Oh, that's my mistake. Right there. Bam. That should be a 3. Okay. Disaster averted. So let's start there. Let's get back to here. So we get 4 root 3 minus 6 root 2. So now these are not like terms, and they're not simplifiable anymore, so we are done at 4 root 3 minus 6 root 2. 25. We have 12 over root 5 minus root 2. All right, now we're getting serious. So we're not allowed to have a square root in the bottom of a fraction. Now, if it was just one square root symbol, that would be easy. We could just multiply the top and bottom by that. However, since there's 2 separated by subtraction, we need the conjugate. And the conjugate, if you remember, is the thing that makes it a perfect, not a perfect square, but a difference of squares. So if we multiply by root 5 plus root 2 on the top and bottom, something awesome happens on the bottom, because what we get, oops, I forgot to close that parentheses. What we'll get on top is 12 times root 5 plus 12 times root 2. So the top is kind of messy, but the bottom is going to be root 5 times root 5 is 5. Root 2 times root 2 is 2, but remember one of these is minus, so minus 2. And the reason there's only two things and not three is because we have a minus root 10 because of these two things, and a plus root 10 because of these two things that cancel each other out. So we end up with 12 root 5 plus 12 root 2 all over 3. Oh, we can do some more simplification. Awesome. So, which is the same as writing 12 root 5 over 3 plus 12 root 2 over 3. And so we can reduce these. And so we end up ultimately with 4 root 5 plus 4 root 2. Bam! All right, that was a fun one. Let's see if we can fit one more in before we switch to the next video. 26. Solve the radical equation root 3c plus 5 equals negative 7. First, if we can isolate the root by subtracting 5 from both sides, whoa. So if we can subtract 5 from both sides, bam, bam, we will get root 3c equals negative 12. Right away I can tell that this is going to be no solution because the positive square root, which is what this is saying, can't be a negative number. Anyway, but just for the sake of argument, we can square both sides and then get 3c equals 144 and then get c equals whatever that is. So 360, 90, 120, 40, 8, I guess. Let's try that. 48 times 3, 4, 2, 12, 14, 144. Okay. So 48. So we think the answer is 48. However, if we plug it in here, 48 times 3, which is 144, the square root is 12. So 12 plus 5 cannot equal a negative number. So this would be a no solution. Okay. And we kind of were clued into that right before we did this part here, because the positive root of a number cannot be a negative 12. All right, I'm going to stop this video and we'll get to the next one.